Let's start from the use of RStudio within the Snap4City platform. In this first part, I show you how to work with RStudio with a simple demo using traffic data of Florence municipality, and in particular how to download real-time data from a traffic sensor using API, how to manipulate the data, and how to create simple statistics as the average values by hour. Let's start with the demo. First of all, you need to access to the Snap4City platform, and on the menu, under the Voice Development Tools, you can log into your RStudio machine. Okay. This is the RStudio interface, and for those who had never seen RStudio, it consists in 4 windows. The first is the console section, the second one here is the script section, where you can do your scripting. You can see here two different scripts open, and you can also add another script just clicking on the plus here. Okay, in this way. Okay, now I close the new script. Okay, the most important function in the script section is the run button, this button here. With this button you execute part of the script and actually starts the calculation. The script section sends the code on the console. That is the place where the calculation itself takes place. I do just a simple example. I create a vector. 3, 2, and 1. I run the vector on the console, I check my vector here, and then I create a simple plot, for example. I run the plot, and I can check my plot and see my plot on the plot section here. Okay. Today our goal is pretty different because we want to download data from a traffic sensor in the city of Florence using API. But how do I know the exact name of the sensor or the exact service URI or the exact API? The easiest thing to do is to open the service map to check the name of the sensor. So we open the service map to this link here, and we zoom on the Florence area. So now we are in Florence, and under the voice transversal services on the menu, you can select road sensors. You click on search. In this way you can see on the map all the traffic sensors in the city of Florence. Now, for example, I'm interested in this sensor on Viale Antonio Gramsci. Okay, I click on the sensor. Clicking on it, I can check the name of the sensor, that is Metro 491, and all the measures inside. Okay, if I click now on this button, I can send on my email the link to obtain the data in JSON format, so the API in this particular case, so for this particular metro with a particular service URI. But if I want to download on R the entire list, just the list, not the data, for all service URIs of all service URIs in the area of Florence, I have to select here, insert my email, and then I can select a query and to download in JSON format the entire list of service URI. Okay, go back to our goal. So now I can check on my email the link to obtain results in JSON format, so the API to download the data. I copy this link, I open R again, and paste the API on R. Okay. You can see here the service and the name of the sensor, but in this case we are interested in download data in a specific time interval. So we need to add after the name of the sensor here other two parameters. The first parameter is from time, that represent the time interval and the time interval, that can be equal to, for example, 1 minus day if I want a period of 1 day, or 2 minus hour if I want a period of 2 hours, or for example 7 minus days because I want a period of 1 week. Okay, now the other parameter is the to time parameter that is the end date. So in this case my end date is 2020 04/10, the April 10, T, that is the separator between the date and the time, at 10 a.m. So in this case I'm going to download data from April 3 at 10 a.m. to April 10 at 10 a.m. Okay, now I have my API, but I need an R package to download data on R. So I need to install, if I don't have it, the package JSON Lite, and then upload the package with a function library. It's important to remind that every time you have need to use a package, it has to be uploaded on R with the function library, or in alternative the function require is the same. Okay, now I run this line and this line. Now I can use the function read JSON of the JSON Lite package to download the data. Read. With the option simplify vector equal to true. Oh, sorry. True. If you want to check this function, you can search it on the help on the R documentation here. This is the read JSON. Okay, and you can check here the functionalities. Okay, now I run the code and I can check here this stamp that is a list with all data related to the sensor. To check what's inside the list, I need to use the dollar in this way, temp dollar real time head. With this command I can check all the names of the variables inside the list, and with the command temp dollar real time dollar results or bindings, I can check all the data. Okay, I copy this command because I want to see the dimension of my data set, of my data, real-time data. Okay. This is a matrix of this number of observation and this number of columns. Now I want to put all this data into an empty matrix. So first of all I create the matrix data, for the moment empty, with any values inside, and number of columns equal to 2 because I'm interested in measure time and vehicle flow only, and the number of row okay, equal to the number of row of the temp matrix. So I copy this on it, and I want only the number of row and not column. So in this way I create a data matrix, an empty matrix, and I want to put the names to the data column. So call names of data equal to C. The first column will be the measured time, and the second will be the vehicle flow. Okay, the vehicle flow column. Okay, this is my empty matrix now, all NA and the names of the column here. Okay, now I want to put all the values inside the matrix in this way. Data, I want to put inside the column measure time all the values of the variable measure time. So I search measure time here, and I want the value. Okay, I do the same for the vehicle flow, just changing the name, and I run these two lines. Okay, I can check just clicking here my matrix, okay, with the measure time and the vehicle flow. Now I want to change the nature of this data from a matrix to a data frame using the function as data frame in this way. Data equal to as data frame the data. Okay, now data is a data frame. I can check what's inside data with str function. Oh, str, okay, run. Okay, data is a data frame with this number of observations, this number of variables, and inside the column measured time, that is a factor, a character, and the vehicle flow variable, that is a factor, a character too. So here the problem is that the vehicle flow is not a factor but a number, so I have to change it, and I change it in this way, and I change the column status in this way. Okay, so data dollar vehicle flow has vehicle to has numeric levels, data dollar vehicle flow of data data dollar vehicle flow. Okay, in this way I change the vehicle flow from a factor to a number, and I can check it with str function. Now vehicle flow is a number. Okay, now I can start to manipulate my matrix, and I want to create 4 different columns, one with the date, one with the time, one with the hour, and one with the day of the week. So first of all, I use the function strrepeatTime to convert a character representation, in this case measure time, in this case the measure time, in a date and times format, specifying the time zone to be used for the conversion and the format of the date and time. So parsed strrepeatTime of data $measure time. I specify here the format of the measure time, that is year minus month. Okay, day, t, that is the separator between the date and the time, hour, okay, oh sorry, okay, minutes, and then seconds. Okay, and then I specify the time zone, for example. Okay, or chat is the same. Okay, now you can see here the conversion of the measure time variable. Okay, now I can create the date, the time, the hour, and the week of the day of the week variable in this way, using the format function. Okay, so data, date, format, parse of, in this I want the date using this format. Okay, I can copy this, it's easier. Maybe time here, and I want time in this format here, hour and minutes. Then I want another column with hours, only hours. Okay, and now with another function I create the variables day of the week in this way. So data, day equal to weekdays function as date of the new feature, the new column date. Okay, I run this first, this, and then this. I can check on my data frame. I have now other 4 columns, one with date, time, hours, and day of the week. This is my new data frame. Okay, now I want to after this simple manipulation of data, I want to compute the average vehicle flow, the average values of vehicle flow per day of the week and per hour. To do this, I need the package data table, so I install it, or if it's already installed, I upload the package. So data table with the library function. I run this code, and then I use data, the function dcast, to aggregate the data and create the average values. Okay, now I put here the data frame, and I want to aggregate, to compute the average values per day, per hours, of the variables value bar for the variables vehicle flow, okay, and I want the mean. Okay, now I run this code. This is my new data frame with per day, per hour, the average vehicle flow value. So Friday at midnight, the average value is this. Okay. Now I change the column name of the vehicle flow because it's not, it's not a name but is a dot, so I want to change it. So call names of data of the third column is to be equal to, for example, average flow. Okay. The next step is to create, the next and the last step is to create a plot with the vehicle flow daily trends by day, per day of the week. So I need two R packages. The first is ggplot2 and the package ggalt. So I install it. So I upload the ggplot2 package first, then I upload library ggalt library. Okay, now I can do my plot. I have here the code to compute the plot. Okay, now here I order my data set. That is, the name is different, maybe AVG data AVG. Okay, so sorry, cancel. I changed the name AVG data. Here I change it here and here. Okay, now I order my data set by hour in this way. Okay. Oh, sorry. Oh, here I have to change. Okay, now I order my data set in this way. Okay, day and hour, all the days of the week per hour. Then I create a legend that is the day, because I want to plot the trend per day of the week, and then I can run the plot. Okay, if I zoom here, I can see my plot. That is the trend per day of the week in 24 hours, in a time interval of 24 hours. Okay, obviously we see that the flow is really low despite the area is very traffic. So this is definitely the coronavirus effect, because in a normal situation, here we have we record a vehicle flow about something like 200, not 30. Is pretty low as average vehicle flow number. After this brief introduction to the use of R, let's move on to how to use R within the Snap4City platform. Here our goal is to create some real-time data analytics using RStudio, exploiting IoT application, and in particular on how to create heat maps automatically. And to do this, we need to know as first step how to create a plumberized R script, and we will see what plumberized means, and how to download real-time data using API, in particular data from weather in an area of interest, and how to save heat maps using API. As second step, we need to know how to create an IoT application for real-time data analytics, in particular how to upload the created R script and how to create a Plumber instance. And as third step, we need to know how to visualize the created heat map in a dashboard. So let's start with this first step, the plumberization. Plumber is an R package that converts your existing R code to a web API using special comments. And this package allows you to create a REST API by merely decorating your existing source with special comments, and these comments allow Plumber to make your function available as API endpoint. So to plumberize your code, you can just put the annotation @get and @serializer on the top of the code, and the @get annotation must be followed by the name of the R function that you prefer. In this case, I decided to call my R function with the name Tuscany heatmap, and the @serializer comment has to be followed by the unboxed JSON annotation. This is because if we want to send a response from R to an API client, the object must be serialized into some format that the client can understand. In this case, a JSON format. After adding in the code the Plumber annotation, the second step is to create an R function with the same name of the @get annotation. This shall be a function containing some parameters, the sensor category, bar name, from date time to date time, and heatmap name, in which the heatmap name is the name of your choice. It will be the name of your heatmap. The sensor category is the sub-nature of the sensor, that is the same that you can find on the service map under the voice transversal services here. And the var name is the property that you want to use, in this case air temperature, while to date time and from date time are referred to the time interval for which I want to download the data. In this case, I want to download data from April 14 to 2 hours earlier. So in the step 3, you have to upload all service URIs from the service map in the area of interest. A possibility is to copy this query, just changing the bounding box coordinates with those of your interest. In this case, here the coordinates are related to the Tuscany bounding box. So with the function from JSON, from the JSON-Lite package, you can download the list of service URIs in the area using this annotation here. And you can see in this slide the query used with the bounding box and the specific sensor category. And here you can see part of the list of service URIs. Now, for each service URI, we need to upload data related to the specific time interval. So we create an empty list, and for each service URI, we use an API to download the data to insert in the list created above. In the API, it's necessary to insert the parameter SURI, in this case, related to the service URI, the parameter from date time, and the parameter to date time. And with the function from JSON, you can download all the data. You can see here the entire API with the specific service URI related to this sensor, EBMET Smart 11, and related to this time interval. So, after a data manipulation and interpolation part, we obtain something like this. This is a matrix. This is an interpolated matrix with a column with longitude, a column with latitude, and a column with the interpolated values. Now, we want to save, using APIs, all these values. To do this, we need to create an R list. to save the data using API. Why a list? Is because we want to save the values in JSON format, and in R, the simplest way to do this is using a list. So for each interpolated values, latitude and longitude, you have to create a list of attributes. A list of attributes with the heatmap name, a metric name, the latitude value, longitude values, and the interpolated value with the date and the organization. The metric name here identify the legend for each heatmap and the color scale to be used. So it corresponds to the var name of the R function. In our case will be R temperature, except for PM10 and PM2.5. So now we have to transform their list in a JSON and save heatmap using API. Now we have to use the toJSON function to convert our list into a JSON, and then using these two steps, so 3 final steps, we can save our heatmaps values, interpolated values, using APIs. So you have the JSON array format will be something like this, with a map name, with a metric name, with a description, a latitude, a longitude, a values related to latitude and longitude, to a date, and to an organization. So now we want to create a data analytic IoT application for the automatical creation and visualization of heatmaps on dedicated dashboard. So what you need? You need for Node-RED's node, the Inject node, the Plumber data analytic node, the function, and the single content. So let's start to configure. So first you have this is the flow that you want to create for the automatical creation of heatmaps. Let's start to configure the Inject node. Clicking on the node, you have to change the properties starting from the payload. The JSON format of the payload property has the same notation of their function parameters, so var name, heatmap name from date time and sensor category. Then you have to select interval into the repeat property, and the duration of the interval. In this case, I select 2 hours because I want to create a new heatmap every 2 hours. And after you tick the Inject box, you have to insert here at the end, okay, the name of your Inject node. In this case, the name of my Inject node is our temperature heatmap Tuscany. The second step is to configure the function node in order to dynamically update the date. It means the toDate time parameter of the R function. So after to do that, we can finally configure the Plumber data analytic node. And the important things to note is that the relative URI has to be the same. Has to be the same annotation of the @get. So the Tuscany heatmap annotation. The name has to be Tuscany heatmap. While the name here is the name of the block, in this case heatmap demo. Now I can upload my R script and I can create, just clicking here, a Plumber data analytic. If you want to check the status of your map, you can also configure a single content node starting from the configuration of this function node that is necessary to execute a JavaScript code to visualize the status of the heatmap. Now we can configure the single content node in this way, creating a new dashboard with a new dashboard name and with a specific widget name, in this case Air Temperature Tuscany. Okay, now we want to create a new dashboard in order to visualize our heat maps. To do this, you have to use the wizard, and you have to select the button New Dashboard on the top right corner under the Voice Dashboard Public from the menu, and select and insert the dashboard title, and then select a specific dashboard template, in this case this one. After that, you have to select the heat map option here as high level type. Then you have select a sensor category, so a sub-nature of your sensor. You have to select the measure, so the value type, and then the heat map name, so the value name here. After that, you have to select the multi-data map button and then click on next button. Then you have select the instantiation button to proceed with item creation. So we have created our dashboard. Now we want to select this dashboard and manually insert on it our dashboard, a specific dashboard. So we have to click here on Edit, and then we have select, just clicking here on More Options to modify the widget properties. Now you can change the query to visualize your new heat map, just here, changing the heat map name at the end of this query from here. The name of our map is Air Temperature Tuscany Test, so this one will be the new query. In this slide, you can visualize the new heat map, the Air Temperature Tuscany heat map, and you can find the link of this specific dashboard here. So in this slide, I reported the RStudio documentation for your self-training, and with a lot of example on how to use R. And well, my part is finished, so I want to thank you for your attention.